Okay, we're now back to line 17J, which is part 88, and it's impulse detection SPATS AMADEUS ANTARES ICECUBE Neutrino while SETI. Okay, hold on a second. I gotta put my other light on here. See if I can. There we go. Sorry. Okay. So these are going to be the shorter videos. Some of them will be longer, some of them will be really short. Again, I've divided everything up into individual. So far we've filmed videos 17A up to 17H and I. And now we're working on J. So if you're doing this video series, you want to start at 17A for this section, okay? All the videos are connected, so you just go back with them, or you Google 17A, which would be the index portion of the whole thing. Okay, so we're going to go back here. The math equation is 14, 1, 1, 13, 2, and 1 from the Wild SETI signal from 1977. And I'm going to do my thoughts for it, and then I'm going to show you the stuff that came up with it. So, this is January 20th, 2012, 9:44 p.m. Eastern Standard Time. My thoughts. I did a Google of neutrinos impulse response and got this. Earth's magnetic field, a charged mystery. And then a star exploding and emit particle like neutrinos. So I do some more Google searching and I find some interesting PDF files about neutrinos and tests being conducted from 2008 to 2010 and the results. Also the desire to test neutrinos in the deepest oceans around the world to see how the particles do in that atmospheric pressure. Up in outer space there is an immense pressure, heat, and friction while traveling at high rates of speed. And then the quote, this the use of conventional neutrino telescope methods and technology for detecting neutrinos with energies above 1 eeV from astrophysical sources. This came up to AMADEUS Antares Modules for acoustic detection under the sea is what they plan to use for this type of testing. I'm going to Google neutrinos with energies above 1 eeV to see if we can use this type of speed for a UFO engine idea. The answer seems to be yes, as electron volt came up. See next video for more about that. Now I'll show you all the links that came up with this Google search on the left after we take a look at the diagram of the neutrino test at CERN at Gran Sasso's using a neutrino beam. Then I'm going to read a quote about the test results found in a Physics for Me blog post. So this is what the test was about with these neutrinos. They were just discovered in late 2011, 2012. They were discovered to be able to travel. They were able to make them travel faster than the speed of light from a test. And they're currently doing some new tests to see why they are traveling faster than the speed of light. So it went from CERN to Gran Sasso, and it shows on this map here, I don't know if you can see it or not. This is Gran Sasso here. This is Austria over here. This is some sort of mountain thing. Italy, it says 732 kilometers, and this is CERN. In France, and it said LEP, LHC, SPS, PS, neutrino beam. I'm not sure. So it went right across Gran Sasso at Italy all the way into Switzerland, or CERN, Switzerland and France. Pretty far for it to travel, right? So it's the quote is 6 sigma signal of superluminal neutrinos from APRA. APRA is the name of the testing facility. APRA is a very innovative concept in neutrino detection. Its aim is to detect tau neutrino appearance in a beam of muon neutrinos. Neutrinos seem to be seen by the APRA detector are produced when a high intensity spill of protons from the SPS hits a target in the CERN laboratories. The large flow of pions and kaons results downstream of the collisions. These particles are then focused and allowed to decay to muons and muon neutrinos. and the latter travel underground to the Gran Sasso, where once in a while one of them is detected. I found that on this website, physicsforme.wordpress.com. So January 21st, 2012, 1:52 p.m. Eastern Standard Time. This is when I wrote the notes for this and did the research. Today is January 24th at 9:57 p.m. I love it when bloggers write it in simple terms so we can understand it. So these are the links that came up when I Googled that number. The Earth's magnetic field remains a charged mystery. Star exploding and emit particles like neutrinos and neutrinos. A person's emotional response after witnessing an unsettling picture. Low temperature detectors for neutrinos and dark matter 2. It's from Luis Gonzalez, Metras Dennis Perigali. 1988 Science, 518 pages. It says the impulse response function of the filter is the time reversed average pulse form. This is equivalent to assuming that the pulse form is independent. They were talking about with the neutrinos, the first test they did was a long pulse, and it made the it travel faster. And then they thought, well, we'll shorten the pulse and that'll make it shorter, right? But actually what happened is they got better test results. So I'm assuming it went faster. So it kind of blew them away. The two different tests were not what they were expecting to happen because it goes against one of the theories that we talked about earlier. So the impulse response function of the filter is the time reversed average pulse form. This is equivalent to assuming that the pulse form is independent. That's a low temperature detectors for neutrinos and dark matter. Then there's the electroweak nuclear response and the impulse approximation. That came up. It's a PDF file from iss.fnl.government. Workshop on intersections of nuclear physics with neutrinos and electrons. That's from 2006. Then we have understanding piezo-based sensors for acoustic neutrino detection. And it's from C.L. Neumann, 2007. This is the system's impulse response was obtained. Figure 5 shows an application to a neutrino-like bipolar pressure signal comparing the signal predicted. Astrophysics. Hold on, let me just see what this is over here. Okay, so I'm pulling this stuff out here. So as you know, I always go through the data and then I pull it out over here. Okay, so I'm just going to finish going through the, oh, I better not, it's beside each other. Okay, so the piezo-based sensors, this system's impulse response was obtained from there. Okay, so I'm just going to go over here and see. So it's understanding piezo-based sensors for acoustic neutrino detection. Blech. Sorry, I didn't know what it meant. So I Googled the acoustic neutrino detection to find out what it is, and this comes up. The South Pole Acoustic Test Setup, SPATS, comes up. Okay? So it's the feasibility of acoustic neutrino detection in ice. Design and performance of the South Pole Acoustic Test Setup, SPATS. From S. Bozer, C. Bohm, F. Deschamps, J. Fisher, A. Hallegren, R. Heller, S. Hundert, Mark, K. Krieger, R. Nanhauer, M. Pohl, P. M. Price, K. H. Sulanki, T. Tosi, and J. Vandenbroek. The South Pole Acoustic Test Setup, SPATS, has been built to evaluate the acoustic characteristics of the South Pole ice in the 10 to 100 kilohertz frequency range, so that the feasibility and the specific design of an acoustic neutrino detection array at South Pole can be evaluated. SPATS consists of 3 vertical strings that were deployed in the upper 400 meters of the South Pole cap in January 2007, using the upper part of ice cube holes. The strings form a triangular array with the longest baseline 421 meters. Each of them has 7 stages with 1 transmitter and 1 sensor module. Both are equipped with piezoelectric ceramic elements in order to produce or detect sound. Analog signals are brought to the surface on electric cables where they are digitized by a PC-based data acquisition system. The data from all 3 strings are collected on a master PC in a central facility from which they are sent to the northern hemisphere via a satellite link or locally stored on tape. A technical overview of the SPATS detector and its performance is presented at the Cosmic Ray Conference 2007. Okay. Okay, so I'm going to go back over to here. I'm just going to jump back and forth here. Another link that came up was Astrophysics, Feasibility of Acoustic Neutrino Detection ICE, Design and Performance, Self-Pole Acoustic Test Setup, SPATS. That came up, so then of course I Googled it to find out what it was. And this is all the data that came up, and then I just pulled it out what was important. You can read that if you go to arxiv.org /abs/0807.4676. Again, these links will be posted up on my blog. This one here. Victoria Stafford, A Psychic Investigation. That's where I post the video along with the research notes, and I'll put the links on there as well for you with some pictures for you to refer to if you want to get all the research details from these videos. Okay, unfortunately I only have 11B up on the blog right now. I am videotaping up to 17, line 17. I will be posting the notes. I'm going to try to finish doing 17, filming from 17J to T, get that done, and then I'm going to post a really interesting video for you guys to look at. It's an alien contact message. I had another one come in, another math equation, and I have no idea what it means, and I'm not going to try to figure it out because I don't have the right thing on my computer to do that, unless you guys can suggest where to go for the information, but I'll cover that later. Okay, so my thoughts from January 21st, 2012, 2:00 p.m. Eastern Standard Time. As you can see, I'm working up from the bottom of the page to the top. This is where we find out they are studying acoustic neutrino detection methods with Antares in May 2010. Results were produced by December 2011 and made public. Further testing has started in January 2012. It says studies of acoustic neutrino detection methods with Antares K-graph for the Antares collaboration, 21st of May 2010. The emissions of neutrinos with a wide energy range is predicted from a very high energy phenomena in the universe. Even the current or next generation Cherenkov neutrino telescopes might be too small to detect the faint fluxes expected for cosmic neutrinos, with energies exceeding the EeV scale. The acoustic detection method is a promising option to enlarge the discovery potential in this high energy regime. Okay, again, here's the data over here, and I pulled out what was important. The experience gained with the Antares Amadeus hybrid acoustic setup can also be transferred to future very large volume optical neutrino telescopes, especially for the position calibration of the detector structures using acoustic sensors. And this is, so we Google Amadeus neutrinos, and I find this, January 20th, 2012, 9:52 p.m. Eastern Standard Time. It says Astrophysics, Instrumentation and Methods for Astrophysics, Amadeus, the Acoustic Neutrino Detection System of the Antares Deep Sea Neutrino Telescope. And there's more stuff there. See all the data that came up. So again, I pulled out what was important, and we've got the Amadeus Antares Modules for the acoustic detector under the sea system, which is described in this article, aims at the investigation of techniques for acoustic detection of neutrinos in the deep sea. Now, I thought that was really cool. I didn't know they were doing this. It is integrated into the Antares Neutrino Telescope in the Mediterranean Sea. Its acoustic sensors installed at water depths between 2050 and 2300 meters employ piezoelectric elements for the broadband recordings of signals with frequencies ranging up to 125 kilohertz. The next thing I pulled out was Amadeus allows for extensive studies of both transient signals and ambient noise in the deep sea, as well as signal correlations on several lengths, scales, and localization of acoustic point sources. Thus, the system is excellently suited to assess the background conditions for the measurement of the bipolar pulses expected to originate from neutrino interactions. Again, there's your data. And over here, I put January 21st, 2012, 1:56 p.m. Eastern Standard Time. I was surprised to read that they are doing neutrino deep sea research. How cool. Looking for images, these tests came up with the Amadeus system plus CERN's findings. It was all Greek to me. Deep sea acoustic neutrino detection in the Amadeus system as a multi-purpose acoustic array. Nuclear instruments and methods in physics research, section 8, accelerators, spectrometers, detectors, and associated equipment, 2009. January 21st, 2012, 1:34 p.m. Eastern Standard Time. My thoughts: I did a Google search on neutrino nucleon cross-section at energies beyond 109 EeV and found the data for the next video. Electron volt joules UFO engine. So basically what happened is I took something from this. This only came up to 17i, and then I started going through the different words and I got more and more and more stuff, right? So of course I had to make more videos, right? So the electron volt joules UFO engine is going to be the next video. It's going to show you what kind of components you have to put in to make this UFO engine that they're talking about. I'm going to pull keywords from each Google description in relation to what we are talking about here. Okay, here's all the data on this side here. And it's about Amadeus, and there's the links. I'm going to be posting the links on my blog so you can look at each one. Let's see. Amadeus, the acoustic neutrino detection test system of the Antares Deep Sea Neutrino Telescope. And I think that's it. There's the other ones of reconstruction methods. This is all about DSEEP, so I'm not going to go into it. Constraints on neutrino nucleon interactions at energies of 1 eV with the IceCube Neutrino Observatory. And it shows there's a search for extremely high energy cosmic neutrinos. So that data came up. And I found this picture to find out what on earth it was talking about. This is what that looks like, whatever they made. And this is the IceCube lab. This is the ice top. It says 80 stations, each with 2 ice top Chernobyl detector tanks, 2 optical sensors per tank, and 320 optical sensors. Then it's got, in 2010 there was 79 strings in operation. In 2011 project completion 86 strings. IceCube array. Amanda deep core. So Eiffel Tower. So this is showing the height of the Eiffel Tower, and then it's showing how high this thing is. Wow. See that? It goes up to 228.20 meters. That's how big it is. And the Eiffel Tower is 324 meters. Give you an idea how huge this thing, and it's actually down in the bottom of the ocean. Something else, eh? Anyways, that's all that stuff there. Next we have a neutrino, since we don't. It's an electrically neutral, weakly interacting elementary subatomic particle with half-integer spin, chirality, and a disputed small amount but non-zero mass. It is able to pass through ordinary matter almost unaffected. The neutrino, meaning small neutral one in Italian, is denoted by the Greek letter V or Nu. Neutrinos do not carry electric charge, which means that they are not affected by the electromagnetic forces that act on charged particles such as electrons and protons. Neutrinos are affected only by the weak subatomic force of much shorter range than electromagnetism and gravity, which is relatively weak on the subatomic scale. They are therefore able to travel great distances through matter without being affected by it. Neutrinos are created as a result of a certain type of radioactive decay or nuclear reactions, such as those that take place in the sun, in nuclear reactors, or when cosmic rays hit atoms. There are 3 types or flavors of neutrinos. There's the electron neutrinos, the muon neutrinos, and the tau neutrinos. Each type also has the corresponding antiparticle called an antineutrino with an opposite chirality. Most neutrinos passing through the Earth emanate from the Sun. About 65 billion solar neutrinos per second pass through every square centimeter. That's a lot. Perpendicular to the direction of the Sun in the region of the Earth. In September 2011, neutrinos apparently moving faster than light were detected Since then, the experiment has undergone extensive critique, and efforts to replicate the results, because confirming the results would change our understandings of the theory of relativity. So we already went over the theory of relativity. I think it's Isaac Newton. I hope it's Isaac Newton. I'm really confused right now. I'm just not with it. So this is what is called the neutrino event. That's the graph here. I can't read these words, they're so tiny. So the first use of a hydrogen bubble chamber to detect neutrinos on November 13th, 1970. Now I thought that was fascinating, because 1970, this is when we first talked about neutrinos, and now in 2012 they're actually testing them and finding out how they work. So it's over 35 years for them. A neutrino hit a proton and a hydrogen atom. The collision occurred at the point where 3 tracks emanate onto the right photograph. Yeah. So my thoughts. January 21st, 2012, 2:10 p.m. Eastern Standard Time. Isn't this funny? See the diagram, the neutrino event? I just had a strange thought. The WOW SETI signal received is August 15, 1977. It's 7 years after this test. And neutrinos come up in the data with other things that can be mixed with it. A hydrogen bubble chamber was used to detect neutrinos on November 13, 1970. A neutrino hit a proton in a hydrogen atom. The collision occurred at the point where 3 tracks emanate on the right of the photograph. And I think that's it for that section. Okay, so we're going to go on to 17K next, okay?